All right, you're all expecting to see a couple of problems worked out for Tuesday, okay? And so I'm going to use this time right now just as a little bit of refresher and just a little bit more reinforcement of the rules on how to solve kinematic problems, okay? We're getting better and better as time goes on, but people still have questions, okay? If I just gave you a problem, I need you to be able to look at it, and I need you to be able to know how to start it, all right, and get to that final answer, okay? And a lot of us are using the right method to get to the answer, but let's get everybody there, okay? Sorry for that long pause. What I'll do is, you can see that I've got a problem up here, okay? And I'm going to start this just like I was starting most of the other ones. Whoops. I'm going to go ahead and I'm going to list all the possible variables, right? Distance or displacement, a velocity. This should be an initial velocity, so that makes it the final, all right? Time and acceleration, okay? All right. It says here that a car started from rest. Just looking at that, if it starts from rest, start's just another way of saying initial. It initially started at, okay? And so I'm going to go over to initial, and I'm going to put 0 there, all right? It started at rest, and it accelerated at 9.54 meters per second squared. Look at the word accelerated, okay? For 6.5 seconds. Most of us know that that means time. All right. How much distance was covered? How much distance, displacement? There we go. Okay. Looking at our equations, if you had to look at the equations, I thought I had them around here somewhere. I must have moved them. Anyways, looking at what the possible equations are, we would pick one that needs an x in it, okay? But we don't have any final velocity, so we can't pick one that's got an x and a final velocity. What we need to do is go with this guy. X equals v naught times t plus 1/2 at squared. All right. Now we're just going to fill in some numbers. Okay, we're trying to find x, and we know that v naught is 0. So guess what? 0 times whatever the time is going to be 0. I'm not even going to write it in there. Okay, I'm just going to go with the half of 9.54 times 6.5 squared. Okay. So I only put in the stuff that really matters at this point. This doesn't matter because it's going to be 0. All right. Half of 9.54 is 4.77. And I'm going to multiply that by 6.5 squared, and that's 42.25. And if I multiply that out, I get 201.5 meters. Okay. And you know what? That seems reasonable for 6.5 seconds for a car that's going at nearly the speed of what gravity pulls. I mean, that seems reasonable. It's not out of whack to think that it went half the distance around a track, all right, in 6.5 seconds. Okay? That problem's done. You've solved it. You wrote down all the units, possible units. You wrote down your knowns and your unknown, okay? And we picked the equation that fit, all right? That's it. I'm going to go over to one more problem. This has 2 sections, okay? And so this does not look like a lot of information. A ball is thrown vertically upward with a speed of 25 meters per second. How high does it rise? So, you know, this is one of those cases where I think a picture is going to help us out. You've got a ball, and it's thrown upwards, okay? It starts off at 25 meters per second. What's it doing up here? Well, it comes to a final velocity of rest, and so it's 0 meters per second. So this is v naught, and this is v, okay? Well, what slowed it down? The same thing that makes it speed up when it falls to Earth. and that's gravity. And we know that gravity speeds things up at 9.8 meters per second squared. Guess what? It also slows things down at that same amount. So that's another given. Look at that. We've got 1, 2, 3 givens here. Okay? And I think that's enough, depending on what the question wants to know. The question wants to know, how high does it rise? Well, that's a distance or a displacement. And so the last thing is x. What is it? Okay? So we've got x, v, v naught, and a. You go to your equation list. I sure wish I had that sitting here. If you go to your equation list, you're going to find one that says this. Okay? Lots of stuff to fill in here. V, in this case, was 0. And so we got 0 squared is 0. V naught is 25. We got to square it. Okay? Plus 2 times 9.8, and x is what's left. Okay? How am I going to get rid of something that's a positive number being added over here? I'm going to subtract it out. And so that happens to be 625 when you square it. So I'm going to subtract that out of both sides. Okay? So you got negative 625 is equal to, I just did that, 2 times 9.8, that happens to be 19.6, all right, and x. Now, one thing, because it's slowed down, this is a negative, so I'm going to bring this negative all the way through, okay? Because it was slowing down, we call that negative acceleration or deceleration. What's left? I got something here being multiplied. Do the opposite. I'm going to divide, canceling that. See, I got to be left with only one little thing over here on this side, and it's got to be left with just a letter. And so divide by negative 19.6. Okay? It's a little sloppy, but I'm sorry. This is how we've got it right on here. This ends up being 31.9 meters. And so what'd you figure out? You figured out that if I throw it this hard, all right, gravity should allow that to rise up nearly 32 meters before it comes to a stop. Okay? That's a pretty good fast launch, by the way. Okay? So that's part A, and I hope I didn't go down into my camera view there. I'm going to now, if you want to pause it, go ahead and pause it, because I'm going to do part B. But I still want to see this part up here. So I'm going to erase, okay? Pause it if you need to. All right. We still have all the same information here for part B. Nothing's really changed. We did figure something out. We figured out how high it would go, okay? But this one wants to know, how long does it take to reach its highest point? And so that's a t. So now instead of an x that we're solving for, we're solving for t, and we don't know it. We want to know how long is it going to take. All this stuff is the same, okay? Well, we've got a v over there. We've got a v naught. We've got a, and we're solving for t. So there's the equation that's got those pieces in it, okay? What are we solving for? That last little t over there. Got to find all this other stuff and get it out of that side of the equal sign, all right? So v is still 0. We started off at 25. We have a negative 9.8 deceleration, and t. Doing the same thing. I'm going to subtract out my 25 because it's being added here. Negative 25 is equal to negative 9.8 t, and we're just going to divide both sides by negative 9.8, and boop, t is going to be left to negative 2.5, I'm sorry, that's a negative 25 divided by negative 9.8, and that's 2.55 seconds, okay? All right, in conclusion, pictures help sometimes. Writing down the knowns is a must, writing down the unknown, and then looking, okay, V naught, A, and T. Yeah, I got an equation that pulls all that stuff together. Then you just got to know the simple rules used in math to isolate that one unknown, okay? Hope this didn't take a little bit longer. It may have taken a little longer than I was hoping, but hopefully this helps. Come in on Tuesday with these answers, okay? Nice job. See ya.